Hello students, I hope you all are doing fantastic out there. So I'm here with the second part of exercise 21b. Okay, we have already completed the first part, that is question number 1 in our previous video, and today we'll start from question number 2 onward. So let's begin. So this is question number 2. The first and the second conditions are given to us and we are asked to prove this. First condition is x cos a plus y sin a equals to m, and the second condition is x sin a minus y cos a is n. So if these are the two conditions, then we are asked to prove this: x square plus y square equals to m square plus n square. Okay, very easy sum. You just need to focus this. LHS equals to, so we are asked to prove this, isn't it? X square plus y square plus m square plus n square, isn't it? So RHS equals to, because why am I using RHS here? Because we are given the values of m and n, isn't it? So RHS equals to, you can use the RHS and prove LHS. Okay, either you can use LHS or prove RHS. Both the things are valid, but here we cannot use LHS because the values of m and n are given to us, so we must use RHS here. So RHS is of this equation. RHS is m square plus n square, isn't it? M square plus n square. From this m square plus n square, we are asked to prove x square plus y square. So let's put the value of m and n. What is the value of m? M is x cos a plus y sin a is m, isn't it? Instead of m, I write x cos a plus y sin a whole square. This is m, isn't it? X cos a plus y sin a is m, so m is squared, so we must put square, plus n square. N square means, first we write the value of n. What is the value of n? X sin a minus y cos a, this is n, isn't it? N means x sin a minus y cos a, x sin a minus y cos a, this is n. So n is squared, so you must put square. Now let us apply the formula a square plus b square. Okay, you can see this is a, this is b, so a plus b whole square is a square. A square means x square cos square a square plus 2ab, 2a is x cos a is a, b is y sin a, 2ab plus b square is y sin a square, isn't it? So y square sin square a, b square means whole thing should be squared, so y sin a whole square means y square sin square a, plus here we have a minus b whole square, isn't it? Let me write this properly. Here we have x sin a is a and minus y cos a is b. A minus b whole square. That means a square is x sin square a, x square sin square a whole square means this square, isn't it? Minus 2ab, 2a is x sin a is a, and b is y cos a, plus b square is y square cos square a, isn't it? Y cos a whole square means y cos a whole square means this square applies to both the numbers, so y square cos square a, isn't it? So instead of writing like this, I write straight away y square cos square a. So we got this. So now this 2 plus 2x cos a y sin a, 2x cos a y sin a, isn't it? See, 2 into x into cos a into y into sin a, isn't it? All are multiplied, so 2x into y is xy cos a sin a. Here 2x into y is xy cos a sin a, isn't it? So these two are same numbers but opposite sign, you can cancel this. Okay, now we have x cos square a, and let's make the angle similar. Okay, x cos square a, x sin square a, these two numbers, you can see x square cos square a, x square sin square a. Let's write together x square cos square a x square sin square a plus x square sin square a. Now we have this and this, isn't it? Plus y square sin square a plus y square cos square a. Are you getting me? Yes. So this x square and x square can be taken common. X square within the bracket remains cos square a plus this x square is out, so sin square a plus, so we can take y square common from here, y square, so within the bracket remains sin square a plus this y square is out, so cos square a. This means x square cos square a plus sin square a is 1, isn't it? Plus this is y, so y square into sin square a plus cos square a is 1, isn't it? So x square into 1 is x square plus y square into 1 is y square. You see here, cos square a plus sin square a is 1. If this was a and this was b, then that would not be 1, okay? The angle should be same. If this is a, this should also be a. If this is theta, this should also be theta. If this is b, this should also be b. Cos square a plus sin square b is not equal to 1. Please keep this in mind. Angle should be similar. So angle a, angle a. Cos square a plus sin square a is 1. Here sin square a plus cos square a is 1. Okay. So x square into 1 is x square plus y square into 1 is y square. So this is what we have in the left hand side, isn't it? So equals to LHS. So we used RHS and proved LHS, hence proved. So let's move to question number 3. Okay, let's do question number 3 from exercise 21b. Okay, we are given with the condition m equals to a sec a plus b tan a and n equals to a tan a plus b sec a. These two are the given conditions and we are asked to prove this. M square minus n square equals to a square minus b square. This is what we are asked to prove. M square minus n square equals to a square minus b square. Okay, so left hand side LHS equals to m square minus n square, isn't it? This is what we have in the left hand side. So using this we are asked to prove a square minus b square. So let's put the value of m. M means a sec a plus b tan a. So m means a sec a plus b tan a. This is m, isn't it? M is a sec a plus b tan a. This is m. M is squared, so we must put a square. Minus, this is minus n square, isn't it? So n is a tan a plus b sec a. So instead of n we write a tan a plus b sec a. So n is squared, so n is squared. So what we do is we put the formula a plus b whole square. Very simple formula, isn't it? A plus b whole square means a square plus 2ab a, isn't it? This is a, 2ab, little bit at a sec a, okay? 2ab, b is b tan a plus b square tan square a. Are you getting me? A plus b whole square means a square plus 2ab plus b square tan square a minus, so let's put bracket, because when there is minus sign, the sign of every number changes, isn't it? So let's put bracket first and then we'll begin, okay, later on. So a plus b whole square means a square minus, so this is plus, okay, 2ab, a is a tan a, b is b sec a, plus b square. B square is b square sec square a, isn't it? B square sec square a. So bracket close. Now a square sec square a plus 2a sec a dot b tan a plus b square tan square a minus into plus is minus a square tan square a minus into plus is minus 2a tan a b sec a, okay, minus into plus minus b square sec square a. If you would understand this, to change the sign we should have skipped this step, okay, we could have skipped this step, but to make you understand, to make you more clear, I just put the bracket here. Now we have plus 2a sec a plus plus 2a sec a dot b tan a, here 2a sec a b tan a, isn't it? 2a tan a sec a b and b, same thing. So let's cancel this out, isn't it? Now a sec square a minus a tan square a, we write these two together, okay. A square sec square a minus a square tan square a plus, we write this two, b square tan square a minus b square sec square a, okay, we write this, where is a b square sec square a. Now let's take a common here, a square common here. If a square is taken common, what remains within the bracket is sec square a minus this a square is taken common. Now tan square a remains within the bracket, tan square a. Let's take minus sign common from here, okay, minus and b square, so minus b square. So when we take minus sign common out, that minus into this plus becomes minus, okay. Now the number which are negative will become positive and the number which are positive will become negative, okay. So sec square a was minus, now it will become plus sec square a. Now this tan square a was plus, now this will become minus tan square a. Are you getting me? Because we took minus sign common, and b square is also taken common, so sec square a minus tan square a. Now a square sec square a minus tan square a means 1, this is minus b square, again sec square a minus tan square a means 1, so a square into 1 is a square, isn't it, minus b square into 1 is b square. So this is what we have in the right hand side, isn't it, equals to RHS, hence proved. I hope we got this. Now let us move on to the next question, that is question number 4, okay. So question number 4 of exercise 21b, okay. So we keep on with the three conditions: x equals to r sin a cos b, y equals to r sin a sin b, and z equals to r cos a. So we are asked to prove this: x square plus y square plus z square equals to r square, isn't it? So let's start from the left hand side. In the left hand side we have LHS equals to x square plus y square plus z square. This is what we have in the left hand side, isn't it? So first let us write the value of x. What is x? X is r sin a cos b. X means r sin a cos b, isn't it? This is x. X means r sin a cos b. So x is squared, isn't it, here, but we have squared. So x squared means this whole thing is squared. So whole thing is squared means you can square it individually like this, plus y squared. So first let us write the value of y. What is y? Y is r sin a sin b. r sine A sine B, isn't it? Y is r sine A sine B. So y is squared, means y is whole squared. So that whole squared can be written individually like this, isn't it? Plus we have z squared. First let us write the value of z. Z is r cos A. So r cos A is z. So z squared means we must square this whole number, isn't it? So r square cos square A. Now from these two numbers, okay, I take r square common and sin square A and sin square A common. You can see r square sin square A, r square sin square A in both the numbers. So let's take this common number out. R square sin square A is taken common out. So within the bracket remains cos square B plus sin square B, isn't it? Plus r square, this we should not forget, cos square A. Okay, now this is r square sin square A and cos square B plus sin square B is 1. See here, please understand this, the angle is B here also and here also. The angle should be same, then only the value will be 1. Okay, cos square theta plus sin square theta is 1, cos square beta plus sin square beta is 1, cos square alpha plus sin square alpha is 1, cos square A plus sin square A is 1, but cos square A plus sin square B is never equal to 1. Okay, cos square A plus sin square B is never equal to 1. Please keep this in mind. Angles are same, so cos square B plus sin square B is 1. Plus we have r square cos square A. Okay, so this thing into 1 is same thing, r square sin square A into 1 is r square sin square A. So you can take r square common from here and here, r square is taken common. Within the bracket remains sin square A into 1 is sin square A plus this r square is taken common out, so cos square A remains within the bracket, isn't it? So here also we have sin square A plus cos square A, angle is same, AA. So sin square A plus cos square A means 1. Okay, so r square into 1 is r square. This is what we have in the right hand side, isn't it? So hence proved. Oh, this is RHS. RHS. Okay, now let us do question number 5 from exercise 21B. Prove trigonometrical identities, isn't it? So we are given with the two conditions, sin A plus cos A equals to m and sec A plus cosec A equals to n. So we are asked to prove this equals to this, n whole m square minus 1 equals to 2m, isn't it? So let's begin. In the left hand side we have n m square minus 1. So we are going to use this and prove this equals to 2m. Okay, so let's put the value of n and m. What is n? N is sec A plus cosec A. Sec A plus cosec A, this is n. And m is, what is m? M is sin A plus cos A. Sin A plus cos A, this is m, isn't it? So m is squared, so we must square this, minus 1, isn't it? So this is sec A plus cosec A. Sec A, for the time being we copy as it is. Okay, cosec A into, let's put the formula a plus b whole square in this expression. A plus b whole square means a square plus 2ab plus b square, isn't it? Sin is a and cos is b. Okay, a square plus 2ab plus b square and minus 1. Okay, if you can understand this, sin square a plus cos square a is 1, isn't it? Sin square a and cos square a is 1. So 1 plus 1 and minus 1 can be cancelled, but let me write that. Okay, sec a can be written as 1 upon cos A plus cosec A can be written as 1 upon sin A, isn't it? So let me write this together, sin A square A plus cos A square A, sin square A plus cos square A plus 2 sin A cos A, 2 sin A dot cos A minus 1, isn't it? So let's take the LCM of cos A and sin A. LCM will be cos A sin A, cos A into sin A. In the numerator we have cos A into sin A gives this, so sin A into 1 is sin A, plus sin A into cos A gives this, so cos A into 1 is cos A. So here we have sin square A plus cos square A means 1 plus 2 sin A cos A, 2 sin A cos A and minus 1. So this plus 1 and minus 1 can be cancelled, isn't it? So in the numerator we have 2 sin A cos A into sin A plus cos A, isn't it, upon cos A sin A. So let me write this, okay. Sin A plus cos A whole upon sin A into cos A into sin A, cos A into sin A. Actually this could have been cancelled earlier, but I didn't cancel to make you clear, okay. This bracket means into, we have 2 sin A cos A, 2 sin A dot cos A, isn't it? So this sin A cos A and sin A cos A can be cancelled. So 2 into sin A plus cos A we have, let me continue here, okay. 2 into sin A plus cos A, 2 into sin A plus cos A, isn't it? So 2 into sin A plus cos A is, sin A plus cos A is m, so this is 2m. We have 2m in the right hand side equals to RHS, hence proved. I hope you got this. Now let us move on to the next question, question number 6. Okay, now let us prove question number 6. We have three conditions here. X equals to r cos A cos B and y equals to r cos A sin B and z equals to r sin A, isn't it? And we are asked to use these conditions and prove this equation. X square plus y square plus z square equals to r square. So let's begin. LHS equals to x square plus y square plus z square, isn't it? This is LHS. We are going to use this and prove r square, okay. So first let us put the value of x. What is x? X is r cos A cos B. X is r cos A dot cos B. This is x, isn't it? X means r cos A cos B. So x is squared, so we must whole square this. Whole squared means you can square individually, isn't it? A, B, C whole squared can be written as A square, B square, C square, isn't it? The same thing. Okay, now plus y square. What is the value of y given to us? R cos A sin B. R cos A dot sin B. So y is also squared, so whole squared means we can square individually, plus z squared, isn't it? So what is z? Z is r sin A, r sin A, and z is also squared, so whole squared means this squared, okay. Now from here we take r cos square A, r cos square A common, okay. R square cos square A, r square cos square A is taken common. R square cos square A is taken common. So within the bracket remains cos square B plus this is taken common, so sin square B, sin square B plus r square sin square A. This should not be forgotten, okay. So cos square B plus sin square B is 1, okay, but cos square A plus sin square B is never equal to 1. Please understand this. Please remember this. The angle should be same, then only cos square theta plus sin square theta will be 1. Cos square alpha plus sin square alpha will be 1. Cos square x plus sin square x will be 1. But cos square something plus sin square different thing is never equal to 1. Okay, keep this in mind. So this is r square cos square a, and this is 1, isn't it? Cos square b plus sin square b is 1. So we write 1 here. Plus we have r square sin square a. Are you getting me? So this r square and r square can be taken common. R square is taken common. So within the bracket cos square a into 1, cos square a, plus this r square is taken common, so sin square a. So this is r square cos square a plus sin square a, sin square a plus cos square a, same thing. So this is 1. So r square into 1 is r square equals to RHS, isn't it? Hence proved RHS. The last question from this exercise, exercise 21b, that is question number 7. Okay, we are given two conditions. Number one is cos a upon cos b equals to m, and another is cos a upon sin b equals to n. These two are the given conditions, and we are asked to prove this equation: m square plus n square into cos square b equals to n square. Okay, so let's write the left hand side of that equation. LHS equals to, we have m square plus n square whole cos square b. This is what we have in the left hand side, and we are going to use this and prove this equals to n square, isn't it? So let's put the value of m and n. Okay, first. So m means cos a upon cos b, cos a upon cos b. This is m. So if I have a upon b whole squared, I can write this, because this squared is for both the numbers, numerator and denominator, that is a and b. Okay, so I can write this as a square upon b square individually, isn't it? This square is for both the number, so a squared and b squared, a squared upon b squared. So same thing I'm going to do here. Okay, so m means cos a upon cos b, cos a upon cos b is m, so m is squared, means the whole thing is squared, isn't it? That means I can put the square individually, plus n. What is n? N is cos a upon sin b, cos a upon sin b. So n is squared, means I can put the square individually, into cos square b, isn't it? So let's take the LCM cos square b and sin square b. The LCM will be cos square b dot sin square b, isn't it? So cos square b into sin square b gives us this thing. So sin square b into cos square a, cos square a dot sin square b, plus sin square b into cos square b gives us this thing. So cos square b into cos square a, cos square a dot cos square b, this two, cos square a dot cos square b, dot means into. Okay, so here we have cos square b. Now this cos square b and cos square b can be cancelled, so we need n square, isn't it? So cos square a and cos square a can be taken common out, cos square a is taken common. Within the bracket remains sin square b, sin square b. Okay, plus this cos square a is taken common, so cos square b whole upon sin square b, isn't it? So sin square b plus cos square b is 1, sin square b plus cos square b means 1, so this gives us cos square a upon sin square b, isn't it? This means 1, sin square b plus cos square b, the angles are same, b, b, sin square b plus cos square b is 1, so 1 into cos square a is cos square a, and in the denominator we have sin square b. So cos square a upon sin square b can be written as cos a upon sin b whole square, this square can be written as whole square, isn't it? So cos A upon sin B is cos A upon sin B, cos A upon sin B, cos A upon sin B is n, cos A upon sin B is n, isn't it? So this square comes here. So this is right hand side, isn't it? Equals to RHS. Hence proved. I hope you got this. Please take the screenshot. Thank you so much for watching this video. I hope you understood the concept from exercise 21B. So stay blessed, stay happy and keep learning. Okay, thank you.